Hello everybody, this is the Biology Exam Review Worksheet for Grade 8, Semester 3 at the International School of Innovation. Let's start by some notes, starting with the lesson about allergy. What is allergy? What causes allergy? What is the meaning of allergy? Some people they have allergy to pollen, some people they have nut allergy, peanut allergy. Some people they are allergic to milk, other they are allergic to some animals, other they are allergic to dust, some plants, some kinds of plants, sure, other they are allergic to some fruits or vegetables. So how can we define allergen? What is allergen? To start with, what is allergen? Allergens are not normally pathogenic substances. They are not normally pathogenic. These harmless substances, they start an exaggerated immune response that we refer to allergy. So allergen, they are not normally pathogenic. For example, if some persons are allergic to strawberry, other they are not allergic to strawberry, it's not pathogenic. It's not normal. It's abnormal case. So let's start with allergic reactions. We have four main types. We have skin contact, we have by injection, by ingestion, or by inhalation. Skin contact, we have poison plants, animal dander, we have pollen, and we have latex. Injection, like the bee sting, for example, or medications, mainly creams and so on, or medication that are injected inside your body. We have ingestion by medications or nuts and shellfish. Inhalation, we have pollen, dust, mold and mildew, and we have animal dander. So first we have allergen, and we have their effects on individuals, mainly dust or dust mites or pollen, hair, and so on. They cause hay fever. Industrial smoke, they cause asthma. Bee venom, they can cause edema. Some chemicals or some textile, they cause eczema. These ones, they are delayed effect, while others, they have an immediate effect. Types of allergies we talked about before, the same ideas, the same types of allergies by skin contact, ingestion, digestion, or injection, or inhalation. So activated cells during allergic responses or allergic reactions. Mainly these cells, they are called mast cells. What happens during allergic response? What do they do during an allergic response? You have to know what's the difference between the granulated and degranulated mast cells. So these are histamine granules that are responsible for the allergic reaction. So activated cells. During allergic reactions, first we have granulated, they contain granules. During allergic reactions, these granulated mast cells become degranulated mast cells. These degranulated mast cells, they release the granules. So histamine granules, they are released. Here we see figures of the degranulation of mast cells. These mast cells, they are granulated. During allergic reaction, they become degranulated mast cells. So this figure shows granulated mast cells whenever they become degranulated mast cells. Baby Celine and her allergy. This baby Celine has allergy to some types of fruits, mainly strawberry. So what will happen? Upon first contact, the no symptoms appear. While upon first contact, what happens? The granulated mast cells do remain granulated. Upon first contact with the allergen, no symptoms of allergy appear. The mast cells are still in the granulated form. B lymphocytes secrete specific antibodies against the allergen. This antibodies bind to the mast cells, and this is called the sensitization reaction. Upon first contact, this will happen. Antibody production, sensitization when antibody binds to histamine producing cells. Upon the first contact, no symptoms. Upon the first contact, sorry, no symptoms. Upon the second contact, symptoms start to appear. Redness, edema, you have some rash of the skin, and other symptoms. So what happens upon the second contact? Upon the second contact with the same allergen, the symptoms of allergy start to appear. The antibodies on the mast cells, they bind the allergen. This leads to the release of the histamine, which leads to the appearance of the symptoms. Mast cells are now in the form of degranulated form. This is called the allergic response. Upon second contact, allergen binding to sensitized histamine-producing cells, mast cells, histamine release, allergic reaction start with the appearance of symptoms. This graph shows the number of granulated mast cells upon the development of an allergic reaction. As you see, the number of granulated was about 8 in 1 milliliter of blood. This decreases by time to reach about less than 1 or approximately 1 after 9 days. Can we treat allergies? This is the big question. Big question? It has the answer. Histamine binds to its receptor during allergic reaction, and this leads to the appearance of the allergic symptoms. All that antihistamine drugs may do is to bind to the histamine-specific receptors, so that histamine they can bind. By occupying these receptors, histamine can bind so no symptoms appear. As such, the symptoms are stopped, no symptoms, but we may not totally stop the allergic response. In this case, of this allergy, the prevention is better than the cure. What is vaccination? Vaccination is a preparation containing antigenic material, whole live microorganism, dead microorganism, attenuated, which is meaning harmless microorganism, toxoid, harmless form of toxin, preparation of harmless antigens, or injection into vein or muscle, or maybe it is oral. Now we move to the principle of vaccination. What is the principle of vaccination? It is to reduce the virulence of pathogenic agents without destroying their antigenic specificity. How can we do this? Either by heating or by the action of some chemical substances. This is the toxins plus physiological liquids, including formalin, about 0.6%, incubation at 37 degrees Celsius, and we have toxins having lost their poison. So what's vaccination? Vaccination launches a primary immune reaction without the existence of the disease, meaning that vaccine injection circulation of attenuated microbe in the organism, as spleen level stimulation of lymphocytes, production of antibodies, and memory lymphocytes. This graph shows the vaccination carried out in different steps, rate of antibodies in blood, first injection of antibodies or first injection of vaccine, second injection, here the third vaccine injection, and we see here booster injection, what happens for the level of antibodies in blood. So active versus passive immunity. Active immunity, this immunity where the body is actively producing antibodies to fight infection. Example, you have a throat infection and you are actively creating antibodies to fight it. Vaccination is an injection of weakened strain of an infectious microbe or pathogen that causes the body to undergo active immunity, thus producing antibodies. While the passive immunity, this is the immunity where antibodies are given to a person from the blood of another person or animal. This immunity only lasts for a short period of time. Example, breastfeeding mother, they pass antibodies to their children through their milk. So this is called a passive immunity. Here show the figure about the active and the passive immunity. As we said about the baby and the child and its mother, the passive. There are some diseases. For example, about the smallpox, mortality about 20 to 30% died. Survivors often left blind and disfigured with scabs. Clinical tetanus, spores deposit in tissue. We have wound, burn, ulcer, compound fracture, operative wounds, drug injection, tetanus, neonatal infection of umbilical stamp, and many others. These are some of the diseases for goes aboard the vaccination. Malaria. Malaria, as we know, is most widely spread through Africa. Malaria infects an estimated 300 million people and is known to be spread by mosquitoes, transfusions, and shared hypodermic needles. Control of mosquito populations has led to declines in malaria in many areas. So infected individuals can be treated they can be treated with a variety of medicines. However, some of the sporozoans that cause malaria have developed immunity to some of employed medicines, and this is the figure of causing malaria. This is an example, not to study this. We have measles, we have the chickenpox. Now, vaccination. These are some diseases that are caused by vaccination, and some of the symptoms, some of the scabs, some of the edema, swelling, and the pain that's caused by these diseases. Vaccination is an active method. Why? Because the organism develops its own immune methods of defenses. Here we have vaccination launches an immune response and assures the appearance of memory lymphocytes. Booster injections launch in the organism a secondary response against different antigen. The secondary immune response is more rapid and effective than the primary immune. Moving to question number 1, drinking allergy. One hot day, Danny returned home with a strawberry milkshake for his mother and father. Three of them enjoyed the cold drink. On another day, the father passed by the same shop and got a strawberry milkshake for his family members. A few minutes after drinking it, the mother noticed rash, meaning that red spots, all over her son's neck. His eyes turned to be red, his mouth got swollen, and he started vomiting. The healthy parent rushed to the hospital, where Danny was diagnosed as having an allergy against strawberry. So pick out from the text the disorder that Danny suffered from. He has strawberry allergy or allergy against strawberry. What is the cause of this disorder? The cause is mainly strawberry. So pick out from the text the symptoms. What are the symptoms? Cause first Danny suffered from is go for strawberry allergy. Strawberry allergy or allergy from strawberry. What is the cause for this disorder? Mainly strawberry. It's the cause. 43. What are the symptoms of this disease? The symptoms are 1. We have rash. 2. We have red eyes. 3. We have the mouth got swollen, or you can say swollen mouth. And 4. We have what's known by vomiting. Now moving to question number 2, skin grafting. As shown in the figure below, 2 experiments were performed on adult mice, trying to transfer a skin patch from the back of the neck of mouse A and from the neck of mouse A to the back of mouse B. So you try to transfer from the back to the neck of mouse A as shown in experiment number 1 and from the neck of mouse A to the back of mouse B as shown in experiment 2. The results in each case are as well indicated. Here in experiment 1, we did a transfer of a skin from the back to the neck of the same mouse A. The graft is accepted, while in the second experiment, we performed a transfer of skin from the neck of mouse A to the back of mouse B. The graft is rejected. Here we have figure legend. This is an important part. This means this arrow means transfer of a skin graft, and this arrow means the result. As shown, you have to describe the above shown experiments. In the describe, you don't have to add any sentences any terms, any statements as they come in the figure, you have to state them. 2. Interpret these experiments. 3. Deduce the type of graft. And 4. You have to explain the result in each experiment. So let's start with the first part. Description. You have to say in experiment 1, a transfer of a skin graft is done within the same body of mouse A. The graft is accepted. In experiment 2, a transfer of skin graft is done from mouse A to mouse B. The graft is rejected. This is description as they come in the figure. I didn't add any additional information. Even though I know the cause of the rejection or I know the cause of acceptance, I don't have to mention this since this is description. Describe, I have to state them. Copy, paste. Question number 2. Interpret these experiments. So after the transfer of a skin graft within the same body of mouse A, here we can add additional information if I know it. The graft is accepted, while after the transfer of a skin graft between different mice A and B, the graft is rejected. What does this indicate? This indicates that the graft is dependent on the relationship and the origin of graft between the donor and the recipient. Here I don't have to say the similarity between HLA molecules since it's not mentioned in the text. Deduce the type of graft. In experiment 1 within the same body is called autograft, and in experiment 2 it's called allograft. Moving to question number 3. How do antihistamines work? How do they work? We're going to say, so baby Marwa was born in Tyre. Her parents took good care of her, especially that they heard it many times that people living in coastal areas may develop a special type of allergy, asthma. On her first day at school, the class was filled with dust. Marwa came back to home and told her mother how nice the first day was. On her second day at school, in presence of dust, Marwa started sneezing, coughing, and suddenly she had very short breath. So her teacher took her to the hospital, where she turned out to have asthma. Pick out from the text the type of allergy that Marwa has and the allergen that causes this. Type of allergy is called asthma, and the allergen it's called dust. The symptoms of allergy, they are sneezing, we have coughing, and we have short breath. Trying to understand how the symptoms of the allergy appear, the amount of histamine in blood was measured in rat A that's allergic to dust as well. The adjacent graph shows the variation of the amount of histamine in blood as a function of time in days, upon first and upon the second contact. This one, upon the first contact of dust, the amount of histamine in blood was about 1 AU or better units, while upon the second contact at day 6, the amount of histamine started to increase to reach about 10 at day 10 and stay constant till the end, which is about 12 days. So what is the posed problem in this question? The posed problem is, how do the symptoms of allergy appear? What is the cause of this? Interpret the result shown in this graph. What can you use? So after the first contact with dust, the amount of histamine in blood they remain constant at 1 AU till the first. There is a second contact with the same antigen, which is the dust. So where it increases to reach about 10 AU at day 10 and remain constant till the end of the experiment, which is day 12. What does this indicate? This indicates that histamine are released upon the second contact with dust and not the first one. What can we deduce? We can deduce that the second response triggers or excites or facilitates the release of histamine. Which type of cells is activated during these allergic responses? They are called mast cells. In which form? In day 3, before they release granule, they are called granulated cells. At day 10, when they release granule, they are called degranulated. So, symptoms. How do the symptoms of allergy? This is the posed problem in the form of question. This is the posed problem. And interpret after the first contact with dust, the amount of histamine in blood remains constant at 1 AU till the second contact with dust at day 6, where it increases to reach 10 AU and remains constant till the end. What does this indicate? This indicates that histamines are raised upon the second contact and not the first one. What can we deduce? We can deduce that the second contact triggers the release of histamine. What are the cells? They are called mast cells. You have to know how to draw the granulated and the degranulated mast cells. In day 3 they are granulated, and in day 10 they are degranulated mast cells. So to understand how antihistamines medicines taken during allergic response work, several experiments were performed. At day 1, injection of histamine. Symptoms of allergy appear when histamine binds to its receptors. At day 2, injection of histamine and antihistamine medicine. So symptoms of allergy stop and histamine cannot bind to its receptors. At day 3, injection of blue stained histamine and green stained antihistamine. The receptors become green. They bind to a green substance. Interpret these experiments. So, after the injection of histamine in experiment 1, the symptoms of allergy appear when histamine binds to its receptor. What does this indicate? This indicates that histamine binding to its receptor stimulates the appearance of the symptoms, while after the injection of histamine and antihistamine medicine in experiment 2, the symptoms stop and the histamine can't bind. So what does this indicate? This indicates that antihistamine block the binding site of histamine. 3. Injection of blue stained histamine and green stained antihistamine. After the injection of blue stained histamine and the green stained antihistamine, the receptors bind to green substance. This indicates that antihistamine has higher affinity to histamine receptors. What can we conclude? We can conclude that the antihistamine block the binding of histamine to its receptor, thus they stop the effects of histamine, which is the appearance of the symptoms. That's all. This is a very important question. A similar question is going to be in your exam, so study this question. This is a very important one, a very important question about how do antihistamine drugs or antihistamine medicines work. So study this question very well. This is a very important question, and good luck, guys. Bye bye.